So welcome to this latest video on 162 Maths, and in this video we'll be going over some past exam GCSE Maths questions on bearings. Now as always, I'll include a copy of the questions that we go through in this video as a link in the description, along with lesson links that go over this topic in greater detail. Now before we get started working through some past exam questions related to bearings, let's just have a quick overview over what it is you need to know and other topics that these questions can sometimes be linked to. So the first thing you need to know is clearly the three rules of bearings. Now the three rules of bearings are that the first rule is that you always start from a north line, you always go in a clockwise direction, and you always write bearings as a 3-digit integer. Now the next thing is really important is make sure you have practice and learn how to read questions carefully. Now, one of the most important bits of information when dealing with approaching a bearings question, where a lot of students tend to make silly mistakes, is by failing to read the question carefully. So make sure you're aware of which position you're starting from and which position you're ending from. Do not assume that the first letter you see is what you start at and the last letter is where you're ending on, because depending on the language that's used to describe the directions, it can be quite confusing. So for example, A to B is where you start at A, end to B, but B from A means that you're starting at A and ending at B. So again, be careful of that. The next thing is back bearings. Now this is usually when a diagram has not been drawn to scale. So for example, on the diagram you can on the screen you can see A to B. So if I just draw a line connecting A to B, now the bearing of A to B is this angle here going in a clockwise direction, so it's this angle here. Now at a guess, let's just say that that is 110. Now a question might ask you is to work out the bearing of B to A. Now if the diagram's not been drawn to scale, then that angle that they're questioning here is actually this angle here. Now without having to measure, if I just look at this question in its entirety, and let's go for this colour. So here, if I just draw a continuing line of that blue line, then I can see that this angle here, this part of the angle, is going to be the same as 110. Why? Because it's corresponding. It's like an F angle. Then to work out this bit here underneath, well, this green part is 180 because that's a straight line. So that means that the bearing of B to A is going to be 180 plus 110, which is 290 degrees, which makes sense because it is a reflex angle. Alternately, what I could have done is worked out what this angle here is, and let me just call that orange, and this angle here is going to be 70 degrees. Why? Because it's co-interior, and therefore to work out this angle here, which is a B to A, I can then do 360, take away 70, and that gives me the same answer of 290. And again, that's without going nowhere near a protractor or an angle measurer. I can do that just based on facts of what I know about angles on parallel lines and angles around a point. So again, don't forget the basics. Now, other topics that bearing questions are often linked to is the most obvious one, which is drawing and measuring angles. Now this is only when your diagram has been drawn to scale. Most questions will say not to scale, in which therefore you do not go anywhere near your protractor. It's going to be basically using your knowledge of angles and straight lines. Again, another thing that's sometimes connected to is scale drawings, but again that tends to be more at a basic level rather than a more high level of maths. But typical topics that it's linked to is Pythagoras and trigonometry. More so trigonometry because it involves angles and lengths. Now, one thing that is missing on this particular section in terms of bearings is compass points. Now, it's really important you do know your compass points. So if I just create a little bit of space here and just draw a set of compass points. So here I've got north, east, south, west. So starting at north, east is going to be at 90, south is at 180, and west is at 270, going in a clockwise direction. Now if I incorporate northeast, then this angle here is going to be 45, southeast is going to be 135, southwest is going to be 225, and northwest is going to be an angle of 315. Now these are all angles that you do need to know. Now sometimes the bearing might not be given, but it might give you a compass point, so it's really important that you do know what angle each of those compass points are at, remembering the 3 rules of bearings, and you need to go in a clockwise direction. Even when going anti-clockwise might be quicker and easier, you've always got to go in a clockwise direction. Now, a little reminder that if you want an access of these questions, all you need to do is just simply click on the link in the description. Alternatively, you can do it on screen. However, that might be difficult for questions that involve actually measuring with a protractor and doing some scale drawings. But again, obviously, I'll leave that to you to decide. So looking at question 1, it says the diagram shows the positions of 2 boats, A and B. Work out the bearing of A and B. Now, remember that this is not being drawn to scale accurately, so we can't use our protractor or ruler. No, it's actually we didn't need a ruler because we're just looking at the bearing. So here it's important we know which boat we're starting at. So it says from A from B, which means that we're starting at B and we are ending at A. So starting at B, the bearing going in a clockwise direction. So the angle I want to measure is this angle here, which I'm highlighting in green. Now, to look at that, well, I know that that makes a false turn with the angle of 120. So B to A is going to be 360 minus 120, which gives me a final answer of 240. It's in 3 digits, so there is my final answer. Then moving on to question 2, it says here is a map showing the location of 2 towns, and the question is asking us to measure the bearing of west wind from Eagle Town. So I'm starting at Eagle Town and my end destination is west wind. So what I need to do is I need to draw a north line from Eagle Town, and again this is going to be incredibly awkward to do on the computer, so just bear with me, like so. And then we need to do the exact same from west wind. And it doesn't matter how long the line is. Now, one thing I did forget to mention is that what helps is drawing a diagram if you don't have a diagram, but also labeling the diagram as well. So if you haven't got a diagram, draw one, and if you have got one, make use of it. So then from this, what we then got to do is then we want to work out the angle starting at Eagle Town to west wind. So I want to measure this angle here. Now, if you've got protractor and you haven't got a 360 angle measurer, then obviously this is going to be quite awkward. But one tactic I would strongly recommend is if you make use of straight lines, I know that this part of the angle is 180. So technically, all I then need to do is measure this little angle here. Now, if you do it correctly and you've printed this off, then this angle here should be 24 degrees. So the bearing of Eagle Town to west wind is going to be equal to 180 plus 24, which gives me an answer of 214 degrees. Now, depending on your measuring, the mark scheme does allow any answer between 212 and 216 inclusive of those numbers. Moving on to question 3, it says the diagram shows the position of a school S and a college C, and it's not been drawn to scale. It says Rosie says the bearing of the school from college is 0.35. Explain why Rosie is wrong. Well, again, looking at this, the angle that we are wanting from going from school from college is this angle here. So what she has worked out, so Rosie has calculated the bearing of school to college, not college to school. And there we go. So something along those lines would be fine. Alternatively, what you could say is if she swaps those two things around, it will therefore be correct. It then says for 3b, write down the 3-figure bearing of the college from school. So for this, if we go back to the diagram, now the green angle is what I'm trying to work out. So again, a couple of ways in which we could do this. We could draw a straight line from this. I know that this angle here is 35 because it's corresponding to this angle here. And I know that this angle here is 180. So it's going to be 35 plus 180, which gives me an answer of 215. Alternatively, what I could have also done is worked out this angle here because it's co-interior with the 35. So that's going to be 180 minus 35, which is 145. And then do 360 minus 145, which equals 215. So exactly the same answer. Moving on to question 4, it says the diagram shows the position of a ship P, and it says for 4a, the lighthouse L is 25 kilometers from P on a bearing of 060 degrees. Draw a scale diagram to show the position of L. Use 1 centimeter equals 5 kilometers. Now for this one, it's going to be very difficult for me to do this one accurately, so let me just show you what you need to do. So first things first, you put your protractor on point P, and what you want to do is you want to measure an angle of 60 degrees. So if I just fictitiously just draw a line, which I believe is around 60 degrees. Again, do not put your protractors against the computer screen. So this angle here is 60 degrees. Now, if 1 centimeter represents 5 kilometers, I need to draw a line of 5 centimeters and just mark it on the line, and I can label that as L, and that would be my correct answer. Then for part B, it says write down the bearing of P from L. So if I draw a north line from L, what the question is asking me is to measure this angle here. So again, using my knowledge, this is going to be 60. So this is 180. So L to P is going to be 60 plus 180, which is 240 degrees. Alternately, I could have done this angle here, which is 120, and then do 360 minus 120, which equals 240. So exactly the same answer. Now looking at question 4c, it says a ship sails on a bearing of 120 degrees from its original position until it's at T, which is due south from L. How far is T from L? You must use a sketch, but must not use a scale diagram. So if we go back to the diagram, now due south of L is somewhere along here. So it's along that dotted line. Now it says that in the question that it's starting at its original position of P and it's travelling on a bearing of 120. Now 120 I would say is about there. So this angle here is 120, which means that this angle here is 60 degrees. So if I just draw that out again, so this is point P, this is L, and this point here will be T. And what the question is asking me is to work out the distance from T from L. So it's asking me to work out this distance here. Now I know that this distance here is 25, and I know that this angle here is 60. Now from this diagram, I can then work out what this angle here is, which I've just marked on the diagram I've just drawn here. Well, that's going to be 180, take away 120, which is 60, which basically means that this triangle here is going to be a equilateral triangle, which means that all the sides are going to be the same. So that means that all the sides would be 25, 25. So therefore, the distance from T to L is going to be 25 kilometers. Then moving on to question 5, it says that the bearing of P from Q is 270. What is the bearing of Q from P? So again, if I do a little diagram, and it says the bearing of P from Q is 270. So this is Q, and that's my north line, and 270 is here, so P is going to be there, and this angle here is 270. Now the question's then asking what's the bearing from P to Q. So drawing a north line from P, it's asking me what this angle here is going to be. Well, that's going to be at 90 degrees, so it's going to be 0, 90. Then moving on to question 6, it says B and C are ships, A is a port, B is due south from A, angle BAC is equal to 48 degrees, AB is equal to AC, and the question is asking us to work out the bearing of B from C, and again it's not drawn accurately. So looking at this triangle, I can see that the angle that I'm wanting is B from C, so I'm wanting to know what this angle here is. So that is what I'm going to call X. So looking at the diagram, I can see it's an isosceles triangle, so I can first of all work out what these two angles here are going to be. Now this angle here is simply going to be 180 minus 48 divided by 2, which gives me an answer of 66. So that's 66 and that's 66. Then to work out this angle here, which if I just colour blue, now that is going to be also 66 because it is corresponding an F angle with the angle ABC. So then I know that this angle here is, in which I'm running out of colours, let's go for purple, so this angle here is 180, so therefore the bearing from B from C, or C to B, is going to be equal to 180 plus 66, which gives me an answer of 246 degrees. Moving on to question 7, it says that B is 8 kilometers due south from A and 8 kilometers due east from C. Work out the bearing of C from A. So I'm going from A to C. So again, drawing a north line from A, and drawing a line from C, that basically what I'm wanting is this angle here. So I'll just call that X. Now one thing I can see is that I've got a right angle triangle. So if I take that triangle and just flip it on its side, that this angle here is what I'm wanting. Now in terms of what I've labelled, that's going to be B, that's going to be C, and that's going to be A. And it's the angle of CAB which I'm wanting. Now C to B is 8, A to B is 8. So then working out what X is going to be, I'm going to be using tan. So I've got tan X equals 8 over 8. So X equals the inverse tan of 1, which gives me an answer of 45. So this angle here is 45. I know that this angle here is 180, so it's going to be 180 plus 45, which gives me an answer of 225. Then for question 8, it says that a ship is going to sail from A to B, and it says Lana works out that the ship needs to sail on a bearing of 34 degrees. Why must Lana be wrong? Well, if they're sailing from A to B, then they're going to be sailing along this line here, and if I draw a north line, then this is the bearing that I'm wanting. Now, as you can see, the bearing of A to B is obtuse and 0.34 degrees is acute. So you could say something along those lines. You could also say that 0.34 degrees is going in the opposite direction. It's actually going to be going up in that direction. You could also say something along the lines which is allowed on the mark scheme, that basically going from A to B is going to cut across the land. So again, that's something that you also need to be aware of. Now you could also work out what the actual angle is going to be, and they would accept an angle of 212 to 216, as an appropriate angle for them to look at. So again, if you did give the correct answer, your answer needs to be between 212 and 216 to get the single mark. Then moving on to question 9, it says the diagram shows the position of 3 points B, C and T, and question 9a says calculate the distance in meters between C and T. So it's asking me to work out this distance here. As you can see, we've got a right angle triangle, so I'm going to be using Pythagoras. So here I've got x squared equals 230 squared plus 160 squared. So x squared equals 78500. So then x equals the square root of 78500, which gives me an answer of 280.2, and that's been rounded to 1 decimal place. Then moving on to 9b, it says work out the bearing of T from C. So then if I go back to the diagram, I'm wanting T from C, I'm actually wanting to know this angle here. So if I just call that Y, well, let's call it C. So in order for me to work that out, if I work out this angle here, which I just call Y, I then know that tan Y equals 160 over 230. So then Y is going to equal the inverse tan of 160 over 230. So Y equals, and it's going to be 34.8. So then if this is 34.8, then to work out this blue angle, it's going to be 90 minus 34.8, which gives me an answer of 55.2 degrees, and that's to 1 decimal place, but I need to give it as a bearing, so it's going to be 0.55. So the answer for 9b, is going to be 0.55. Moving on to question 10, so our last bearing question, it says that a ship sails from A to B and then from B to C. B is 22 miles from A and on a bearing of 0.30, and C is 14 miles from B on a bearing of 108. And the question is asking me to work out the direct distance from A to C. Now the first thing I need to do is draw a straight line from A to C, and this is what I'm working. Now looking at this, I can see I've got a triangle. It's non-right angle, so I'm going to be using advanced trigonometry. So knowing that I've got 3 sides where one of them is x, I need to work out what this angle here is. Now in order to do that, I can work out this angle because it's co-interior with this angle here. So that's going to be 180 minus 30, which is 150. So that's 150. So I can then work out what this angle here is going to be by doing 360 minus 150 minus 108, which gives me an angle of 102. So then taking that triangle out, I've got this angle which is 102, this length here which is 22, this length here which is 14, and this length x, which is what I'm wanting. So I'm going to be using the cosine rule, so x squared equals 22 squared plus 14 squared minus 2 times 22 times 14 times cos of 102. So then typing that all into my calculator, I get an x squared value of 808.0736 blah blah blah. And then if I square root that answer, I get an answer of 28.4, and that's to 1 decimal place, and that's in miles.